So this is the first lesson in solving equations, and in this lesson we're going to look at how to solve a one-step problem that has addition as a part of it. And the whole idea here in solving any of these problems as we look through this set is going to be to try to find the value of x. And in some cases you can just look at them and see what the value of x would be, what number plus 5 equals 12. It's kind of a mental math problem. But what I'm going to do is give you a procedure that will work regardless of what type of problem it is, and even on more complex problems this procedure will help you to solve these. So the idea here in solving equations is actually to undo the equation. So what we're going to do is sort of work backwards and take this apart and work back to the beginning, because we already have the solution. We know that x plus 5 equals 12. We wanted to know what this number originally was in order to have that solution. So here's the general technique. You're always going to do the opposite of whatever's there. So since we have a plus 5, we're going to actually add a negative 5 to both sides of the equal sign. And the way I'm going to set this up is up and down, like we would do a sort of a normal math problem. If we can work our way down as adding down or subtracting down on a normal problem. So if we see here that x just comes down, there's nothing that we're going to take away or add to the x. But we have a positive 5 and a negative 5, and you put those two together, that makes 0, which is the whole reason I chose to do this, adding the opposite of positive 5 to give me a 0 here, and then 12 and a negative 5 put together. You can think of it as subtraction, but really we're just putting together a positive 12 and a negative 5, which means we have a positive 7 left over, so the actual value of x would be 7. And so the rule here, or the procedure, is to add the opposite. So add the opposite of this to both sides of the equal sign. And the rule is you always do the same thing to both sides. So add the opposite to both sides of the equal sign. And then we can come down and clear that out, and we have this value of 7. You can always put it back into check. 7 plus 5 does equal 12. So if our x is 7, then our solution is 12. This idea works whether it's addition or subtraction, but we can think of a problem that has subtraction in it. And in this case, in a one-step situation, we're going to do the same thing we did with addition. We're going to add the opposite to both sides of the equal sign. Always have to do the same thing to both sides of the equal sign. So adding the opposite of a negative 3, sometimes people think of this as subtraction, which you could. This is x minus 3, or you could think of it as x plus a negative 3. So the opposite of this minus 3 is a plus 3 to both sides of the equal sign. And we're going to add down or subtract down, whichever way you want to think of it. And the x just simply comes down. And this becomes a 0, which is what we wanted. And then we put these two together, 14 and 3 makes 17. And it's really the same technique we did with addition. We're just always putting the opposite of whatever operation we have here together to clear that out away from the x, so that we have the x all by itself. And it can always check to see that 17 minus 3 does equal 14. These are very basic, simple problems. The idea is to practice the technique, because when we get to more complex problems, two-step and beyond, we'll be needing this technique in order to keep track. It's a sort of a bookkeeping method to keep track of whether or not I've done the right things in the right places. So that's one step with a negative part, or subtraction if you want to think of it that way. So what happens if we have multiplication in the picture? Well, again, we're going to do something opposite of what's there, because we're working backwards to a part that was in the beginning, we have the answer 4 times x. When you have a number in front of a letter, it's multiplication. So 4 multiplied by whatever the number x is equals 28. And again, mentally you could probably do this one without this technique, but practicing the technique is helpful for more complex problems. So the idea is, in this case, since this is multiplication, we're going to divide or do the opposite operation. Divide both sides of the equal sign by the multiplier of x. So what have we multiplied x by? We're going to now divide both sides by that. So since 4 is the multiplier of x, we're going to divide both sides by 4. And so now what happens is 4 divided by 4 is 1. 4/4 is 1 whole. So we have 1x, or just x, and 28 divided by 4, which makes 7. And so again, this could be checked if I said 4 times 7 equals 28. I'm not going to use the multiplication sign because it looks too much like an x. Parentheses work the same way as multiplication, so this times this, 4 times 7 is 28, and so that works. So when it's multiplication, I divide, and so one more, there's 4 different one-step problems. So if I have division, which is what fractions are, so you might say, well, this looks like a fraction. It is. It's x divided by 5 equals 11, so what number divided by 5 equals 11? And if you've noticed in all of the things we've done, whether it was addition, subtraction, or multiplication, we've always used the opposite operation. So the opposite of division would be multiplication. So I'm going to multiply both sides by what we call the coefficient, the divisor of x. So the divisor of x in this case is a 5. So we're going to multiply both sides by that divisor of x. So if we multiply both sides, multiply this first side, I'm going to rewrite it down here so you can see it a little bit better. So I multiply this side times 5, so I really have 5 times x over 5 equals 11 times 5. Again, I'm not going to use the multiplication sign because it looks too much like an x at this point. So what that does is it does what I wanted to do, is make x all by itself. 5 divided by 5 is 1. So this really, some people say, well, this cancels. It really becomes 1. And so I have 1x, or just x, equals 11 times 5, or 55. And so my technique for all one-step problems is simply to do the opposite operation to both sides of whatever it is that's attached to the x or near the x. So this one, in this case, there's just one step. All I need to do is multiply both sides by 5. And that will make the 5 go away here, and I'll be left with x equals 11 times 5, or 55. When I'm looking at multiplication, I divide both sides by the multiplier or coefficient of x. So both sides divided by 4, and I get my solution. When it's subtraction, which is really just working with a negative number, all I do is put it together with the positive or opposite of negative 3 is positive 3, which makes the 3 go away, and I'm left with the x, and then put those two together, and you have the solution for x. And then back to one-step addition, which again, the idea is if I add the opposite, that goes away. 5 will go away if I add the opposite of it. Makes a 0. And then we have x equals those two put together. The biggest challenge in some of these is going to be dealing with positive and negative numbers. So if you have other problems you run into and you're not so good with integers, that may become sort of a sticking point with these. But the idea is always the same. You do the opposite operation to both sides and isolate x, and then you have its solution. And that's how you solve one-step equations.